मला काही आवाज म्यूट नहीं क्या म्यूट है आवाज हेलो
यस सर।
सभी को नमस्कार। मैं सुनीत काशेव
नमस्कार सर।
राज्य के हरदा जिले में स्थित टिमरनी तहसील के शासकीय स्नातक महाविद्यालय प्राचार्य सहायक प्राध्यापक मीनाक्षी यादव मैडम एवं गणित विभाग के विभागाध्यक्ष डॉक्टर नीरज मालवी सर की ओर से एवं समस्त स्टाफ की ओर से इस अंतर्राष्ट्रीय वेबिनार से जुड़े सभी अतिथियों का, विद्वज्जनों का, शोधार्थियों का हार्दिक हार्दिक वंदन करता हूं, अभिनंदन करता हूं। जैसा आप सभी को विदित है, शासकीय स्नातक महाविद्यालय टिमरनी गणित एवं कंप्यूटर साइंस विभाग की ओर से रियल लाइफ एप्लीकेशन एंड इम्पैक्ट ऑफ मैथमेटिक्स एंड कंप्यूटर साइंस विषय पर इस अंतर्राष्ट्रीय सेमिनार का वर्चुअली आयोजन किया जा रहा है। शासकीय स्नातक महाविद्यालय टिमरनी तहसील में स्थित स्नातक स्तर का महाविद्यालय है, जिसमें 3 परंपरागत पाठ्यक्रमों के साथ 10 स्ववित्तीय पाठ्यक्रम संचालित हैं और वर्तमान में इसमें विद्यार्थियों की संख्या लगभग 3100 है। नेट गाइडलाइन के अनुसार और महाविद्यालय के विद्यार्थियों, स्टाफ और विभिन्न विश्वविद्यालय और महाविद्यालयों के शोधार्थियों और विद्वज्जनों में उत्साह, ऊर्जा का संचार करने के लिए, उनकी शैक्षणिक एवं शैक्षणेतर गतिविधियों में वृद्धि करने के लिए इस प्रकार के वेबिनार का आयोजन हम विगत 2-3 वर्षों से लगातार कर रहे हैं और उसी कड़ी में आज हमने गणित विभाग के अंतर्गत इस वेबिनार का आयोजन किया है। आज के हमारे इस अंतर्राष्ट्रीय वेबिनार का मुख्य आतिथ्य स्वीकार किया है डॉक्टर गीता मोदी मैडम, प्राध्यापक एवं विभागाध्यक्ष मोतीलाल विज्ञान महाविद्यालय भोपाल से हमारे बीच हैं। की नोट स्पीकर के रूप में डॉक्टर संतोष कुमार, गणित विषय के प्राध्यापक, तंजानिया से हमारे बीच अपनी बात रखेंगे। एमिनेट स्पीकर के रूप में डॉक्टर उमेश कुमार, चितकारा विश्वविद्यालय पंजाब से, वे अपनी बात रखेंगे। आज हमारे गणित विभाग का एवं महाविद्यालय का प्रयास यही रहेगा कि हम इस वर्चुअली अंतर्राष्ट्रीय वेबिनार के माध्यम से इस विषय पे जो भी चुनौतियां निकल कर आएंगी, जो उसके समाधान होंगे, उन पर चलने का प्रयास करेंगे और जो भी विद्वज्जन, शोधार्थी, सहायक प्राध्यापक और अतिथि विद्वान एवं शिक्षक साथी इससे जुड़े हैं, वे इस विषय का संपूर्ण लाभ लेंगे। एक बार पुनः प्राचार्य शासकीय महाविद्यालय टिमरनी की ओर से मैं इस अंतर्राष्ट्रीय सेमिनार से जुड़े समस्त अतिथियों का पुनः वंदन, अभिनंदन करता हूं और इसी के साथ जो इस सेमिनार को जिन्होंने संयोजित किया है, गणित विभाग के डॉक्टर नीरज मालवी सर, उनसे विनम्र अनुरोध करता हूं कि वे आगे इस सेमिनार का संपूर्ण संचालन करें। आदरणीय मालवी।
Very good afternoon to Honorable Chief Guest Madam Dr. Geeta Modi Madam, respected speakers Dr. Santosh Kumar Sir and Dr. Umesh Kumar Sir, and to dear all participants. I, Dr. Neeraj Malviya, convener of this international seminar, warmly welcome you all on behalf of Internal Quality Assurance Cell of Government Degree College Timarni. As we know very well, life cannot be run systematically without application of mathematics and computer science. So we have decided the topic of this international seminar is real life applications and impact of mathematics and computer science. Now, without wasting of time, I am introducing our Honorable Chief Guest Madam and respected speakers. One. Dr. Geeta Modi Madam. डॉक्टर गीता मोदी मैडम, जब से मैं कॉलेज एजुकेशन में जैसे ही मैंने प्रवेश लिया था, मेरी मेंटर हैं, गुरु हैं और निरंतर मैडम का मार्गदर्शन हमें प्राप्त होता है। मेरा बड़ा सौभाग्य है कि द्वितीय इंटरनेशनल सेमिनार में मैडम मुख्य आतिथ्य ग्रहण कर रही हैं। मैं मैडम का स्वागत करता हूं और अभिनंदन करता हूं। Dr. Geeta Modi Madam, presently working as Professor and Head of Mathematics Department in Government MBM College, Bhopal. She is ex-chairman of Central Board of Studies in MP Higher Education and ex-chairman of Board of Studies in Barkatullah University. During her teaching career of about 38 years, she has taught various courses in pure and applied mathematics. She has published 70 research papers in national and international journals, including SCI journals. So far, she has supervised 21 PhD candidates, 15 awarded and 6 ongoing. She has received award for cutting-edge researchers in international conferences organized by National University, Singapore and South Asia Management Association in 2018. Our first keynote speaker, Dr. Santosh Kumar. He is Associate Professor in Department of Mathematics, University of Dar es Salaam, Tanzania. Dr. Santosh Kumar obtained MPhil and PhD degree in mathematics from Aligarh University. During his teaching career of about 20 years, he has taught various courses in pure mathematics, applied mathematics, and computer applications at undergraduate and at postgraduate level. He has more than 60 research papers to his credit. Many of them are published in various SCI, Scopus, ESCI, Springer and elsewhere journals. So far, he has supervised 3 PhD candidates, 1 ongoing. He has also supervised 19 MSc projects. Besides, he keeps participating in various scientific meetings, conferences in India and abroad. So far, he has delivered over 22 contributed talks. He is reviewer of American Mathematical Society and also the editor of many SCI, Springer, elsewhere journals. He has presented 7 research papers in international conferences. He has also been appointed as an external expert for PhD, MSc Viva and thesis valuation from various universities. He has also published 12 books and 1 book chapter from international publication. इतने समृद्ध अकादमिक बैकग्राउंड को रखने वाले डॉक्टर संतोष कुमार सर का मैं आज के इंटरनेशनल वेबिनार में स्वागत करता हूं। Our second eminent speaker is Dr. Santosh Kumar Lilbhore. He is Dr. Umesh Kumar Lilhore is an associate professor at Chitkara University Institute of Engineering and Technology, Punjab. He received his PhD and MTech in computer science engineering. He has more than 16 years of teaching experience in education, research, and consultancy. He has published more than 80 research articles in leading journals, conference, proceedings, and books of high repute. His research interest mainly includes artificial intelligence, machine learning, IoT, computer security, computational इंटेलिजेंस एंड इंफॉर्मेशन साइंस। डॉक्टर उमेश कुमार सर का मैं आज के इंटरनेशनल सेमिनार में स्वागत करता हूं और यह मेरे लिए अत्यंत गर्व का विषय है कि डॉक्टर उमेश कुमार सर के साथ मुझे साथ में कार्य करने का अवसर प्राप्त हुआ है। और ये भी बताना चाहता हूं कि सर यूएसए रिटर्न हैं, काफ़ी सारा वर्क इन्होंने अमेरिका में भी किया हुआ है और अब निरंतर भारत में सेवाएं दे रहे हैं। डॉक्टर उमेश कुमार सर का मैं इस इंटरनेशनल सेमिनार में स्वागत करता हूं। नाउ आई वुड लाइक टू अवर इंचार्ज प्रिंसिपल डॉक्टर मीनाक्षी यादव मैडम फॉर फॉर्मल इन्विटेशन ऑफ गेस्ट एंड स्पीकर्स एंड ऑल द पार्टिसिपेंट्स।
Namaste सभी को। It is a moment of pleasure to welcome the guests and all the participants. On behalf of the Principal and Government College Timarni, I bid a very warm welcome to all our dignitaries. I convey my regards to the Chief Guest, Dr. Geeta Modi Ma'am, Keynote Speaker Dr. Santosh Kumar and our eminent speaker Dr. Umesh Kumar Lilhore. I wish this webinar enlightens us all with your expertise and knowledge in every possible way. एक बार और आप सभी का स्वागत। नमस्ते। ओवर टू यू सर।
प्रोफेसर मीनाक्षी यादव मैडम के स्वागत भाषण उपरांत मैं हमारे इस इंटरनेशनल सेमिनार का जो मुख्य आतिथ्य ग्रहण कर रही हैं आदरणीय परम श्रद्धेय डॉक्टर गीता मोदी मैडम से अनुरोध करता हूं कि वे अपने आशीर्वचनों से हमें लाभान्वित करने की कृपा करें। डॉक्टर गीता मोदी मैडम।
धन्यवाद नीरज। मेरी आवाज सुनाई दे रही है?
आ रही है आवाज आपकी।
ओके। आज के इंटरनेशनल सेमिनार कम वेबिनार का विषय रियल लाइफ एप्लीकेशन एंड इम्पैक्ट ऑफ मैथमेटिक्स एंड कंप्यूटर्स के चयन हेतु मैं ऑर्गेनाइजिंग टीम को धन्यवाद देती हूं और इसका सफल संचालन हेतु मैं नीरज को भी धन्यवाद देती हूं। मैं अपनी बात अत्यंत सरल भाषा में रखूंगी। आज का युग कंप्यूटर का युग है और कंप्यूटर की सभी गणनाएं गणित पर आधारित होती हैं। हम अपने आसपास के दैनिक जीवन में जो भी घटनाएं देखते हैं वो कहीं ना कहीं गणित से जुड़ी हुई होती हैं। जैसे मानव शरीर का बाहरी हिस्सा रीढ़ की हड्डी के दोनों तरफ सिमेट्रिक होता है, कुछ अपवादों को छोड़कर। तो हम अपने विद्यार्थियों को फर्स्ट ईयर से ही कर्व ट्रेसिंग अर्थात वक्रों का अनुरेखण पढ़ाते हैं और उसमें हम सिमेट्रिक टू एक्स एक्सिस, सिमेट्रिक टू वाई एक्सिस, सिमेट्रिक टू लाइन वाई इक्वल टू एक्स इत्यादि पढ़ाते हैं। तो ये जो मानव शरीर की सिमेट्री है, ये कर्व ट्रेसिंग की जो सिमेट्री पढ़ाते हैं उसका एक अत्यंत अच्छा उदाहरण है। दूसरा, बरसात के मौसम में बनने वाले इंद्रधनुष को हम सभी ने देखा होगा। ये भी एक वैज्ञानिक घटना का ही प्रमाण है, जिसमें जो रंगों का क्रम होता है, हम सभी जानते हैं कि इसमें सबसे ऊपर रेड कलर दिखता है, फिर ऑरेंज दिखता है, फिर येलो, फिर ग्रीन, फिर ब्लू, फिर इंडिगो और फिर वायलेट। तो इनका ये जो क्रम है, हम इंद्रधनुष कहीं से भी देखें, चाहे टिमरनी में दिखे या भोपाल में दिखे या किसी भी हिस्से में, उसका क्रम हमेशा यही होगा। तो ये भी एक गणितीय घटना, वैज्ञानिक घटना का ही प्रमाण है। सभी अपने आसपास पेड़ पौधों की बात करते हैं, पर्यावरण संरक्षण की बात करते हैं। तो पेड़ पौधों में भी हम देखें कि जैसे जिस पेड़ के पत्ते, आम के पत्ते यदि टिमरनी में जिस पैटर्न के हैं, तो वही देश के अन्य हिस्सों में भी होंगे। और पत्ते भी हमेशा सिमेट्रिक होते हैं, उसमें बीच में एक लाइन होती है, उसके आसपास जो है उसकी सिमेट्री होती है। अब हम आते हैं कि दैनिक जीवन में भी गणित का कहाँ कहाँ उपयोग होता है। तो देखिए, अपन देखते हैं कि बहुत पहले से लकड़ी का कहीं ना कहीं यूज होता है, और ये कार्य कारपेंटर करते हैं, और उसको वो बहुत ही बारीकी से नाप कर फर्नीचर बनाते हैं। यानी उनको भी नाप तोल में गणित का पर्याप्त ज्ञान होता है, तभी वो इस कार्य को कुशलता पूर्वक कर पाते हैं। फिर हम देखें कि कहीं पर भी हमारी कॉलेज की बिल्डिंग ले लें, बाकी सब भवन ले लें, तो इसमें जो काम होता है वो सीमेंट और रेत के उपयोग से होता है, और उस भवन की मजबूती सीमेंट और रेत के अनुपात पर निर्भर करती है। यानी जो हम अनुपात पढ़ते हैं कि ये 2:3 है, 3:4 है, बहुत सारी हम 5वीं 6वीं की क्लास से ही हम अनुपात पढ़ना शुरू कर देते हैं। तो ये उसका सबसे अच्छा उपयोग है और सबसे अच्छा उदाहरण है कि हम इसको इस तरीके से देख पाते हैं। फिर बीएससी क्लासेस में हम एक ट्रायंगुलर इनइक्वालिटी पढ़ाते हैं, त्रिभुज असमी का। उसमें हम ऐसा लिखते हैं कि डिस्टेंस बिटवीन एक्स वाई इज लेस आर इक्वल टू डिस्टेंस बिटवीन एक्स जेड प्लस डिस्टेंस बिटवीन जेड वाई। और ये जो जेड पॉइंट है, ये एक्स वाई की स्ट्रेट लाइन पर नहीं है, तो ये हमेशा लेस देन होता है। अब इसका हम अपनी डेली लाइफ में कैसे यूज करते हैं? एक्स पॉइंट पर किसी भी स्टूडेंट का घर है या हमारा घर है, वाई पॉइंट पर कॉलेज है, तो एक्स से वाई तक हम एक स्ट्रेट लाइन खींच दें। ज्यादातर ऐसे रास्ते होते हैं कि एक्स से वाई तक रास्ता बनाया जा सकता हो। जेड कोई पॉइंट है जो कि एक्स से जेड पर जाता है और जेड से वाई पर जाता है। जेड कोई चौराहा है, तो जहां पर ज्यादा जगह होगी वहां से सड़क बनेगी, एक्स से जेड और जेड से वाई। तो जब हम देखेंगे कि एक्स जेड प्लस जेड वाई को यदि हम टोटल करते हैं, तो उसकी लंबाई, उस पाथ की या उस रास्ते की लंबाई एक्स जेड से हमेशा ज्यादा होती है। तो हम क्या करते हैं, अपनी कम समय में दूरी करने के लिए या कम समय में घर से कॉलेज पहुंचने के लिए हम सीधा रास्ता अपनाते हैं, जो कि एक न्यूनतम दूरी है। और ये विद्यार्थी में ये वर्षों से चला आ रहा है, सभी लोग इसका यूज करते हैं। इसका मतलब है कि उन्हें भी इस गणितीय ज्ञान था कि हम शॉर्टेस्ट डिस्टेंस का भी उपयोग कर सकते हैं। एक और चीज के बारे में मैं बताना चाहूंगी कि हमारे विद्यार्थी 10वीं 11वीं से ही मैट्रिक्स के ऊपर बहुत ज्यादा, डिटर्मिनेंट और मैट्रिक्स का चैप्टर है, उन्हें हमेशा पढ़ाया जाता है। तो मैट्रिक्स का यूज करके ही हमने कंप्यूटर में बहुत ज्यादा उसका उपयोग किया है, और जब तक उसे मैट्रिक्स नहीं आएगा कंप्यूटर नहीं आएगा। कंप्यूटर का ज्ञान गणित पर ही आधारित होता है। इसके बारे में मैं दो चीजें बताना चाहूंगी। आजकल पूरे देश में डिजिटल पेमेंट की बात हो रही है, और डिजिटल पेमेंट कंप्यूटर की हेल्प से ही संभव हो पाया है। प्रत्येक बैंक अकाउंट मैट्रिक्स के एक एलिमेंट से एसोसिएट होता है। तभी हम देखते हैं ऑनलाइन लॉगिन करने पर हम लॉगिन आईडी और पासवर्ड डालते हैं, और मैट्रिक्स की हेल्प से रजिस्टर्ड मोबाइल पर एक ओटीपी आता है। अर्थात हमारा अकाउंट कोई दूसरा यूज नहीं कर सकता, और वो हमें सुरक्षा प्रदान करता है। तो हमारे गणित का उपयोग, अब ये हम गणित वाले हैं इसलिए हम गणित की दृष्टि से देखते हैं, लेकिन ये तो जनधन योजना का अकाउंट करने वाला भी इस चीज से परिचित है कि इस तरह की भी कोई क्रिया होती है। ठीक है। अब मशीन भी देखी होगी, हमें करने के लिए डेबिट या क्रेडिट कार्ड का यूज करते हैं। जब हम इस कार्ड को मशीन में डालते हैं और मशीन में वो अमाउंट इंसर्ट कर देते हैं जो हमें पे करना है, तो मशीन हमसे पासवर्ड मांगती है। जब हम उसमें पासवर्ड डालते हैं तो स्क्रीन के ऊपर या तो डॉट डॉट दिखाई देता है, जितने बार जैसे हमने 6 लिखा तो एक डॉट आ जाएगा, कोई दूसरा नंबर लिखा तो फिर दूसरा डॉट आ जाएगा, या उस स्क्रीन के ऊपर कभी कभी ऐसा एक क्रॉस दिखाई देता है। इसका मतलब है हमने जो अंक लिखा है वो किसी और को दिखाई नहीं दे रहा है। जो पासवर्ड का अंक लिखा है उसकी जगह कुछ डॉट या क्रॉस दिखाई दे रहा है। तो ये भी मैट्रिक्स की हेल्प से ही संभव हो पाया है, और इसकी जो एक ब्रांच है मैथमेटिक्स की, क्रिप्टोग्राफी, उसके अंतर्गत इस सभी का अध्ययन किया जाता है, और ये सब भी हमें इस डिजिटल पेमेंट के लिए और सुरक्षित बनाने के लिए किया गया कार्य है। इसके अलावा हम सभी ने ट्रैफिक सिग्नल्स भी देखे होंगे। तो जो ट्रैफिक सिग्नल्स में ग्रीन के बाद येलो होता है, फिर रेड कलर आता है, फिर आपको रुकना है, फिर से वही प्रोसेस होती है। तो ये भी कंप्यूटर के द्वारा ही इसको कंप्यूटराइज करके उस पर कुछ टाइम कर दिया जाता है कि ये 60 सेकंड का होगा या 90 सेकंड का सिग्नल होगा, और वो ऑटोमेटिक ऐसा होता रहता है। इसके अलावा हम सभी लोग घर में घर खर्च का बजट बनाना हो, या रसोई में मसालों का अनुपात किस अनुपात में क्या डलेगा, ये डिसाइड करने के लिए भी हम गणित का ही उपयोग करते हैं। गणित हमारा जीवन से बिल्कुल अपने साथ चलता रहता है। इसका मतलब है ये ऊपर के सभी जो भी मैं प्रयोग बता रही हूँ गणित के, ये कंप्यूटर के युग के उदाहरण हैं। इसका मतलब है क्या प्राचीन काल में गणित का उपयोग नहीं होता था, या पहले लोगों को गणित का ज्ञान नहीं था? तो ऐसा नहीं है। इसके लिए मैं एक अपने ही देश की एक प्राचीन घटना पर एक प्रकाश डालना चाहती हूँ कि हमारे देश में एक राजा पृथ्वीराज चौहान का नाम सभी ने सुना होगा, और जब एक विदेशी आक्रमणकारी मोहम्मद गौरी ने उन पर आक्रमण किया, तो वो पृथ्वीराज चौहान इतने सशक्त राजा थे कि उन्होंने उसे 16 बार परास्त किया था, 16 बार पराजित किया। लेकिन हमारी मानसिकता माफ करने की ज्यादा होती है, तो उन्होंने 16 बार ही उसको, जब भी वो आक्रमण करता हार जाता, फिर भी ये उसको माफ कर देते। पर और वो हर बार 1-2 साल बाद फिर से अपनी सेना जुटा के और फिर आक्रमण करता। तो उसने पुनः 17वीं बार भी आक्रमण किया, और जब 17वीं बार आक्रमण किया मोहम्मद गौरी ने, तो पृथ्वीराज चौहान हार गए और वो उन्हें बंदी बनाकर अपने साथ काबुल अफगानिस्तान ले गया। यानी 16 बार जीतने के बाद भी उसने हार नहीं मानी और वो बराबर आक्रमण करते रहा, और काबुल अफगानिस्तान ले गया, वहां उसकी आंखें फोड़ दी। ये अपने इतिहास की घटना है। अब क्या हुआ कि पृथ्वीराज चौहान के जो राजकवि थे चंद बरदाई, वो पृथ्वीराज से मिलने काबुल पहुंचे और उन्होंने राजा से मिलके एक प्लान बनाया कि हम किस तरीके से इसका बदला ले सकते हैं। उसने मोहम्मद गौरी को बताया कि पृथ्वीराज चौहान जो है वो शब्द भेदी बाण का चलाने में बहुत निपुण है। पर मोहम्मद गौरी को लगा कि ये अंधा व्यक्ति ये काम कैसे कर सकता है, उसे विश्वास नहीं हुआ, वो तो अपनी जीत के उसमें था। तो उसने एक सभा बुलाई और लोहे के ऐसे 7 बड़े बड़े घंटे जैसे टंगवा दिए, निश्चित दूरी पर टंगवा दिए। अब पृथ्वीराज को ऐसा लगा कि ये पृथ्वीराज अंधे थे, तो उन्हें बेड़ियों से आजाद कर दिया गया कि ये अंधा व्यक्ति दौड़ भाग भी नहीं कर सकता और कुछ भी नहीं कर सकता। और उसने राजा जो है वो एक ऊंचे सिंहासन पे बैठ गया और उसने जैसे ही सैनिकों को आदेश दिया घंटा बजाने के लिए, तो वो आवाज पृथ्वीराज चौहान ने सुनी। अब वो आवाज को डिफाइन करने के लिए जो उनके राजकवि थे, उन्होंने गणित का कैसे सहारा लिया ये बताना चाहती हूँ। 4 बांस 24 गज अंगुल अष्ट प्रमाण, ता ऊपर सुल्तान है मत चूको चौहान। और उन्होंने इस कविता में गणित भर के उनको उसकी स्थिति बता दी कि वो कहाँ पर बैठा है। और उन्होंने, वो अंधे थे लेकिन वो आवाज सुन के अपना बाण चला सकते थे, और उन्होंने इसका पूरा उपयोग किया और मोहम्मद गौरी को बाण से मार दिया। मतलब पुराने जमाने में भी गणित का बहुतायात से उपयोग होता था, और हम ऐसे बहुत सारी चीजें ऐसे देख सकते हैं जहां पर हम गणित का उपयोग किन किन तरीकों से हो सकता है। 1 मिनट और लूंगी, और अंत में मैं यही कहना चाहूंगी कि हम अपनी आसपास की घटनाओं को समझें, उनमें कहाँ कहाँ पर गणित दिखाई देता है, वो कहाँ से आया, और उसको हम अच्छे तरीके से दूसरों को भी समझा सकते हैं। यदि हम अपने जीवन में, दैनिक जीवन में सभी जगह गणित ढूंढ पाते हैं, तो इस सेमिनार की बहुत बड़ी सफलता होगी। और मैं आयोजन समिति का और विशेषकर हमारे नीरज मालवीय का बहुत बहुत धन्यवाद करती हूँ कि उन्होंने मुझे बोलने का समय दिया। धन्यवाद। ओवर टू नीरज।
आदरणीय रिस्पेक्टेड गीता मोदी मैडम ने इतने सारे इतिहास से और इतने प्यारे प्यारे एग्जाम्पल दिए, और मैडम ने भव्य शुभारंभ इस इंटरनेशनल सेमिनार का कर दिया है। मैं बहुत बहुत आभारी हूँ मैडम, बहुत धन्यवाद देता हूँ आपको। और ये हमारे लिए अत्यंत गर्व का विषय है कि हमारे आदरणीय प्राचार्य जी को हरदा कलेक्टर ने मीटिंग में बुलाया था, और हमारे लिए अत्यंत गर्व का विषय है कि सर वहाँ की मीटिंग ओवर करके यहाँ आ चुके हैं। मैं हमारे जो प्रिंसिपल हैं रिस्पेक्टेड आदरणीय जिनेंद्र सर से मैं निवेदन करता हूँ कि वे 2 आशीर्वचन कहें और हमारे समस्त अतिथियों का स्वागत करें। आदरणीय JK जैन सर।
इस वर्कशॉप में डॉक्टर गीता मोदी मैडम का मैं स्वागत करता हूं कि उन्होंने अपने इस अमूल्य समय के साथ हम लोगों के साथ भागीदारी करी। साथ ही डॉक्टर संतोष कुमार तंजानिया से विश्वविद्यालय से जो हैं उनका भी मैं बहुत बहुत स्वागत करता हूं कि उन्होंने हमें मार्गदर्शन प्रदान किया और इस वर्कशॉप को सफल बनाने में अपना अमूल्य योगदान दिया। तथा डॉक्टर उमेश कुमार जी पंजाब से, उनका भी बहुत बहुत आभारी हूँ कि उन्होंने इस वर्कशॉप में अपने अमूल्य वचनों से हमें अनुग्रहित किया। मैं सभी का बहुत बहुत आभारी हूँ। धन्यवाद।
रिस्पेक्टेड प्रिंसिपल सर, डॉक्टर जेके जैन सर के फॉर्मल वेलकम के उपरांत हमारे जो फर्स्ट कीनोट स्पीकर हैं, लास्ट ईयर भी हम सहयोग प्रदान किया था। नाउ आई वुड लाइक टू इनवाइट डॉक्टर संतोष कुमार सर फॉर देयर कीनोट एड्रेस। सर, प्लीज वेलकम।
Thank you, Dr. Malvi. First of all, I would like to tell the audience that I am very much thankful to the organizing committee, principal of Government College Timarni, the organizing committee, and especially to Dr. Neeraj Malvi to invite me in this event. I am also welcoming Dr. Geeta Modi, Professor and Head Department of Mathematics, Government MVN College, Bhopal, for the nice talk in this beginning. Thank you all. So, as Dr. Neeraj Malvi told everyone that we are going to discuss something about the applications of mathematics, applications of computer science, and what are the effect of this scenario, how we behave, how we act. Everything I will cover in this talk. So let me share my slides. Can you see my screen?
No, sir.
Check. Can you see my screen now?
नो सर, अभी नहीं दिख रही है।
सागर ये हटाओ स्क्रीन पीछे से। जस्ट होल्ड ऑन, आई एम डूइंग। पीछे से ये हटाओ, कट रहा है ना फोटो। अपने जगह को बैक कर दो।
नो इफेक्ट पे कर दो।
Okay. Now, can you see my screen?
No, sir.
Can you see my screen, Neeraj? But I think somebody else shared the screen because the icon is not on in my computer.
सर
Can
नहीं
you check the screen?
नो सर, नहीं दिख रही।
मैडम आप अपना स्क्रीन ऑफ करेंगी? ऐसा लगता है आपकी स्क्रीन ऑन और की है।
अच्छा,
मेरा आइकन एक्टिव नहीं हो पा रहा है क्योंकि किसी और की स्क्रीन ऑन है।
सचिन कटारिया है ना, इनको बंद कर दीजिए।
मेरे चेक करिए, आई स्क्रीन मेरी?
तो सर अभी नहीं आई है।
आपका किसी का स्क्रीन शेयर हो रहा है ऐसा लगता है। अब आया? हेलो?
यस सर, आ गया।
Yes, sir.
नीरज मेरी
आ गया सर, आ गया।
Okay, thank you. Thank you. So,
Yes, sir.
today's topic is real life applications and impact of mathematics and computer science. Now, I'll cover almost 4 topics in this talk. First, the introduction overall, and then impact of mathematics in society, impact of computer science in society, and real life applications of mathematics and computer science. So we know that mathematics and science is the backbone of any country nowadays. These subjects play an important role in the development of the country. Better science and technology boost the economy of a country. Presently, all the technology implicitly uses the application of science, mathematics. Mathematics and science has contributed mostly in market and industry. So, if we see the current scenario of the world system or world organization, these topics are very important for the development of a nation and for the control on the international and national economic and technological aspect of a nation. Now, if we think about the information technology or the research development, mostly mathematics is involved in all branches. So we can say that this is the key subject area or key subject in the day-to-day life. Briefly, I can say that mathematics provides methods for organizing and structuring knowledge so that when applied to technology, it allows scientists and engineers to produce systematic, reproducible, and transmittable knowledge. In our ancient times, we say that like the crest of a peacock, like a gem on the head of a snake, so is the mathematics at the head of all knowledge. In Hindi, we can say that जैसे मोर के सिर पे कलंगी होती है, जैसे नाग के सिर पे मड़ी होती है, वैसे ही सारी नॉलेजों में जितनी नॉलेज हमारे पास है उन सब में मैथमेटिक्स सबसे ऊपर होता है. And this was given 500 BC in Vedang Jyotish. So we can say that our Indian mathematicians or Indian people know the importance of mathematics far back than the people know in the Europe or in other countries. If we see the remark, this book was written by Carl Friedrich Gauss in 18th century. It says that mathematics is the king of all sciences. That means what our rishis munis realized 500 BC means 2500 years ago. The Europeans realized that just 400 years ago. So we should proud on this knowledge of our ancient people. Now, if we see now the current scenario, how mathematics is impacting the society, I will discuss some of the aspects of the life. Mathematics is of central importance to modern society. It provides the vital underpinning of the knowledge of economy. It is essential in physical sciences, technology, business, financial services, and many areas of ICT. So if we see, if your mathematics is strong, obviously your IQ and reasoning will be strong. You will excel in most of the areas like science and technology, biology, medicine. We are using nowadays too much mathematics in business, financial services. That means mathematics impact in our day-to-day life in the society. If we see more rigorous. It gives the aids in our understanding of the world and good tool for developing mental discipline. Factors like logical and critical thinking, creative ideas, abstract or spatial intelligence, problem-solving capabilities, communication skills. So many aspects of the life are governed by the mathematics education. If we say in the social structure, we can say that mathematics gives the support in all sciences, all technological things, and it gives a boost to our social life or social development. The main aim of the education is that children will earn a good life things in their life. So people think that their kids must study mathematics. Why? Because mathematics gives the background for the engineering science, for medical, for business, for other areas. Even if we see the simple things like accountancy, architecture, banking, business, agriculture, tailoring, carpentry, surveying, everywhere we found the importance of mathematics, whether it is high level or low level. So this gives us a backbone or a back support in different areas in the aspect of social and vocational development of the life. Now, if I go towards spiritual or cultural development, this is very crucial area because in Indian scenario, it is important. If we go to the Vedas, like Madam was talking about Prithviraj Chauhan, I am talking much earlier than that. If we go to Vedas, our rishis defined the exact dimensions of the Vedis. Vedis means where the rishis was burning the fire. हिंदी में बोलूंगा मैं इसको, जो यज्ञ वेदी होती थी जहां पर वो आग जलाते थे, उस यज्ञ वेदी की डायमेंशन वेदों में बहुत ही क्लियर तरीके से डिफाइन की गई है कि उसका कितना लंबाई होना है, कितना चौड़ाई होना है, कितना कुंड का गहराई होगा, ये सारी चीजें. That means our rishis munis knows mathematics and the geometry very well in those days, like 5,000 years ago. We consider that Rig Veda was written sometime 3,000 to 4,000 years back before Christ. That means from now it is almost 5,000 to 6,000 years ago. And that is the amazing thing to our society, our people, that our ancient people knows the geometry, mathematics very well, and they were using in their day-to-day spiritual or cultural life. Now, if I go to next, the recent scenario, we know that some students do ITI. The state governments are running ITI in India. That is, we call it vocational education. There we teach the students carpentry, fitting, tailoring, and some other aspects of the professional life. If we go to the other side, like economic side, we learn economics, business, psychology, architecture, designing. We use the mathematics in surveying, means the trigonometry in surveying. So everywhere, whether it is art side or whether it is science side or whether it is technology or it is vocational training, we are using mathematics, computers everywhere. And they are changing our life. Now, if we see the economics, economy normally, as I said in the beginning, the economy of a country depends upon the development of the country or the knowledge of the people of the country, how they are working, how they are producing the things. So it plays a big role in the economy of a country or of a society. And the high technology systems mostly depends upon the mathematical inputs and outputs and how they are designed. Everywhere the mathematical logic and mathematical tools are involved. Now, if we see the recent scenario, the government is saying that we expect that 20,000, 30,000 cases will arise for COVID-19 in next week. How we are predicting? We are using mathematical modeling. Worldwide countries are doing mathematical modeling. How in first day, second day, third day, fourth day, the cases are coming. So mathematics is heavily involved, means the statistics and the other mathematical branches are heavily involved. Here also we are using computer softwares, computers and mathematics. That means mathematics and computers are helping in medical science, in the social aspects, and also in the biological science. Now, if we go to the different branches, how mathematics is helping us in medical and agriculture, we are easily able to define that nowadays the farmers are using drones to spray the pesticides in the farms. In India now, this system is now in the practice, but in foreign countries it is going on since long. So in agriculture we are using small computers or small drones. In ecology, epidemiology, we can trace the tumor using the mathematics and computers. Cardiological modeling we are using. DNA fingerprinting we are using mathematics. In DNA fingerprinting we use the fixed point theory. So everywhere, even in the recent medicines development, we are using mathematical modeling and mathematics. Now, what I said up to now, everywhere computer was having its role. So we can say computers have supplied infinite resources for learning and made education more flexible and easy to access. Nowadays, we can see that in the classrooms, students are not appearing in the classroom. They are studying at home. How? We are using internets, we are using laptops, we are using mobile phones to connect with the school teachers. And teachers are taking online classes. This is possible because of the development of the computers and technology, ICTs. So we say that computers as well as mathematics, information technologies helping us in our day-to-day life. Next, we can say that computers change a whole lot. Without computers, it was not easy to explore the space. We can see how the galaxies are forming, how the galaxies moving in the space. We can see through the computers and the telescopes. Recent telescopes are using supercomputers. So everywhere we can see the application. Now in the medical sector, I told the recent generic medicine developments, we are using computers and technology. Defense sector, everywhere we are using like robots, we are using in the battlefields. We are using latest technologies like laser technology in the weapons, recent weapons. We are using industrial sector, we are using robots. Nowadays, like in car manufacturing companies, we are using robots to take the heavy parts of the vehicles from one place to another place, and they're fixing the heavy parts in the vehicle. In oil exploration, we are using computer technology. In film industry, we are using computers. फिल्म में कैसे कंप्यूटर यूज करते हैं, मैं थोड़ा सा इसका आइडिया देता हूँ जो बच्चे होंगे, लिसनर होंगे उनके लिए. जब भी कोई एक्टर बहुत मोटा होता है या डायरेक्टर कहता है कि हमें इस फिगर का एक्टर चाहिए या एक्ट्रेस चाहिए, तो हम उसकी जो रियल इमेज है उस इमेज का कॉन्ट्रैक्शन करते हैं और उस कॉन्ट्रैक्शन का फिक्स पॉइंट थ्योरी अप्लाई करके उसका कॉन्ट्रैक्शन करते हैं और उस कॉन्ट्रैक्शन का डायमेंशन सेट करते हैं कि फेस किस रेशियो में कॉन्ट्रैक्ट होना है, मींस कंप्रेस होना है, चेस्ट, ब्रेस्ट, whatever the piece of the body, which ratio they want. So sometimes they want that the age is suppose 50, they must look like 25. So the computer software changes the overlook of the actor according to the demand of the director in the film. ये सारा काम हॉलीवुड में और अब बॉलीवुड में भी हो रहा है. So that is the use of computer science, mathematics, and the recent technology in the film industry. Agriculture, बहुत सारे seeds आ रहे हैं. We develop those seeds in the agriculture research centers. और उसके बाद पहले साइंटिस्ट जो एग्रीकल्चर साइंटिस्ट होते हैं उनको जो है फार्म में डेवलप करने के बाद ग्रो करते हैं. फिर उनका मैथमेटिकल मॉडल के हिसाब से स्टडी किया जाता है. और जब वो पैरामीटर्स मींस टेम्परेचर, वेदर कंडीशंस, क्लाइमेटिक कंडीशंस, ह्यूमिडिटी सब पे अगर वो ठीक होते हैं, उसी के बाद उन सीड्स को हम रिलीज करते हैं फार्मर्स के लिए. तो एग्रीकल्चर में बहुत ही ज्यादा एप्लीकेशन हो रहा है मैथमेटिकल मॉडलिंग, कंप्यूटर और फोरकास्टिंग, स्टैटिस्टिकल फोरकास्टिंग का. फूड टेक्नोलॉजी, अभी हम लोगों को इंडस्ट्री में क्या करना होता है कि जो फ्रूट्स हैं वो एक एक पीस जो है ह्यूमन बीइंग जो है टेस्ट करता है कि ठीक है कि नहीं, और हाथ से चेक करने पे पता नहीं चलता है कि उस पर कोई बैक्टीरिया या वायरस या फंगस लगा हुआ है. अभी रिसेंटली मैंने एक पेपर पब्लिश किया है जर्नल ऑफ फूड एंड टेक्नोलॉजी में. तो उसमें हम लोगों ने जो एआई है उसका यूज किया है, मशीन लर्निंग का यूज किया है और मैथमेटिक्स का यूज किया है. उसमें क्या है कि जो हमारा कैमरा है, एआई कैमरा, वो पूरे के पूरे लॉट जो बंच है उसके फोटो स्कैन करता है और जिस भी फ्रूट पे अगर कोई स्पॉट है तो वो उसको ऑटोमेटिकली इंडिकेट कर देता है कि ये फ्रूट जो है वो ठीक नहीं है. तो जो रोबोट है वो उसको हटा देता है. तो वो एक टेक्नोलॉजी है. अभी हमको एक ट्रक को सॉर्ट आउट करने में बहुत सारे लेबर की जरूरत पड़ती थी, लेकिन उस रोबोट के हेल्प से, उस टेक्नोलॉजी के हेल्प से कुछ ही घंटे में पूरा का पूरा ट्रक का फ्रूट्स जो है वो सॉर्ट हो जाएगा कि कौन सा अच्छा है, कौन सा गलत है, कौन सा नहीं सही है. तो हम मैथमेटिक्स, एआई, मशीन लर्निंग, इन सब का एप्लीकेशन करके फूड टेक्नोलॉजी को बेटर कर रहे हैं. Many more areas we are using computers and other areas. Now, I will discuss the main application of mathematics in real life, how it behaves, how it works. First of all, I will give this example. Whenever the cancer patient goes to the doctors, if it is the spinal side or if it is the chest or breast side cancer, the doctors measure the area of the cancer cells in which area they are affecting the body, and they use their similar triangles for this measurement. Why they do? If they give the radiotherapy or the radiation without measuring, then that radioactive rays or radiation will kill the healthy cells in the body and the patient will be more serious rather than getting cure in the treatment, cure in the radiation treatment. So doctors in advance calculate the area in which they need the radiation therapy on the body, and they use the similar triangles. I calculated by giving some parameters now, and the figure is here. Like Madam Geeta told about the encoding and decoding of the data in computers, in cryptography, in the banking system. So this technology was given by 3 scientists. They were Israeli scientists, Ronald Rivest, Adi Samir, and Leonard Elderman. And they invented the RSA and crypto system for the banking system, which we are using nowadays, and they use the large prime numbers of the number theory. So this is already discussed by Madam, so I will skip this. Now some of the generic examples are there. Land surveying equipments use the trigonometry, means the clinometer. They use during the road construction, measuring the height of the building, trees and other things during the road construction. Also, we can calculate the area of the field, we can calculate the area of the circles and different arc-shaped designs during the construction of the road, tunnels, or the bridges or the buildings. We are also using mathematics in the area of the autocorrelation, like when you want to check whether the crude oil is available in the ground and how far it is from the surface. We send the sound waves in the earth and we record the reflections of those waves. And then by autocorrelation, we calculate that the oil is available here or not. And this process saves a lot of money of the drilling to the oil companies. So this is not only the procedure of drilling or the computer calculation, but it is also economic aspects of this technology or this mathematics. Now, if we think about the earthquakes, we say that this is 4.0 Richter scale. What is that Richter scale? That Richter scale is directly related to the mathematics, and the logarithmic plays here a role, and the logarithmic is a logarithmic value of that intensity gives us the measurement of the Richter scale. So that formula is R is equal to log x over 0.001, and this R is known as the Richter scale or the intensity, which we call it 4.2, 3.1, like that. So this is the simple logarithmic formula which we use in the earthquake technology. Now in lottery, we use normally the outcomes, that means probability theory. So whenever we, जब भी हम किसी डाइस को थ्रो करते हैं तो डाइस नॉर्मली 6 फेस होते हैं और उस पर 1, 2, 3 अप टू 6 नंबर्स लिखा होता है या उस पर डॉट्स बना होता है. तो हमें अगर 1 चाहिए तो हमारी जो प्रोबेबिलिटी है वो 1/6 है. दैट इज द लॉटरी सिस्टम. Now, if we go to the hard mathematics side, like complex analysis, we use discrete Fourier transform and fast Fourier transform algorithms in computer science for the image processing, digital communication, compression, and countless other uses. Now, if you see, I will give you the picture how we change. This is the picture of a beautiful lady. We want to send this photo to other end. So when we want to send this photo to other end, suppose from India to Europe, we transform this picture by using the fast Fourier transform into this form, second form. So this is the Fourier transform of this beautiful figure in this. Now we transfer the data using internet lines or the telephone line, telegraphic lines. Other end, they use the DFT. They use the inverse fast Fourier transform or inverse discrete Fourier transform, and they reconstruct the image at the other end. So we are using here complex analysis, we are using here the Fourier transform, we are using here the computers to transmit data from one end to other end. Now in these music systems, most of the families have these devices in their houses for their kids. So these devices are using convolution of functions or the maps. Whenever a kid wants to listen some sound, they press a button, and this button convolutes that noise which appears from that key. So these devices are using convolution. We call it vintage Emax sampler or EMU. Now 3D rotations, we are using complex analysis. I can show the pictures, how they are behaving. So whenever, if we see the real life, they are like this. These 3 rings are looking like this, means each of them are perpendicular to each other. This is 3D notation of the complex number. Now, when we transform this looks like 3 circular rings. So we are using here these technologies, mathematics in the day-to-day life, in the technological things. Now, if we see the quantum computation, we are using nowadays the quantum, we are working on quantum computers. So, quantum technology is playing very big role nowadays, and in future, the country who have the quantum computers for their computing, they will be the leading powers in the world. So, we are using here this quantum technology or the technology in the crucial airfoil. The aeroplane wings design, we are using it. The complex quantum computer theory we are using. We are using in the flow of the air over the aeroplane wings or the aeroplane body in the space, in the environment or in the space. So these are the applications of complex, the transform or the Fourier transform theory. In medical imaging, we are using Fourier transforms. Complex numbers allows one to see inside the body with accurate precision. Like whenever you go to the CT scan machine, the human body is passing on a stretcher in the machine and the doctors are watching inside the body on the computer screen. What is the problem inside? So to detect the tumors and other things, doctors are using topology, computer science and transform theory with complex numbers. Now in circuits, biological populations, automotive suspensions, everywhere we are using complex numbers, eigenvalue computations and these things. If we go to more detail, Schrödinger equation which describes behavior of the atom, atomic level, we are using complex domain or quantum field theory. Let us go a bit more. We are using this area in signals and systems in electronics engineering. Whenever we send the video signals or audio signals from one TV station to other areas, we use these transform technologies or the things in day-to-day life. UPS is our useful apparatus in the families nowadays. So in UPS, we are using these transforms, like we convert the AC to DC, we store in the battery, and the UPS converts by using the transform technology to AC again. Many other areas like LCD, digital camera, cell phone, FFT, we are using. We are using fixed point theory here for face recognition or for the thumb recognition in the mobiles. So these are some of the applications. MRI machines, deep space signal, picture recover, gas exploration, everywhere we are using these things. Now if you go to the subject wise, we are using real analysis, approximate the polynomials in the orbit system, in the space, Fourier series and approximation, convexity and optimization. If you see the Boolean algebra is the backbone of the computer science. Without Boolean algebra, the current analog computers cannot work. Because our computers, हमारे जो अभी कंप्यूटर हैं वो सिर्फ 0 और 1 दो ही डिजिट मैथमेटिक्स की जानते हैं, उनको ना 2 पता है ना 3 पता है. तो जो कंप्यूटर सिस्टम जो हम यूज कर रहे हैं, लैपटॉप कंप्यूटर आज की डेट में, वो बूलियन अलजेब्रा पे बेस्ड है और वो सारे के सारे कंप्यूटेशन, सारे के सारे स्टोरेज 0 और 1 में ही करते हैं. तो इसलिए बूलियन अलजेब्रा जो है वो कंप्यूटर साइंस की बैकबोन है, या वी कैन से दैट इट इज द बैकबोन ऑफ द कंप्यूटर साइंस. क्रिप्टोलॉजी के बारे में मैडम ने पहले ही बता दिया है. फाइनेंशियल सिस्टम जो है उसमें क्रिप्टोलॉजी जो कि अलजेब्रा की एक ब्रांच है, बहुत ज्यादा एप्लीकेशन है. इन द इंडस्ट्री शेड्यूलिंग टास्क प्रोसेसर्स वी आर यूजिंग heterogeneous and homogeneous things. So these things are very much useful. Now, study of crystal symmetry in chemistry, we are using group theory. If we go to functional analysis, this area has high-end applications. like signal processing for modeling and design, we use the functional analysis techniques. Machine learning in the design of classifiers or spam filters we are using in computer science. Economics, to find the maximum point, we use the fixed point theory or the Nash fixed point theorem, Nash theorem. Image processing, sending and receiving images using wavelet theory. Application of approximation theory in image processing using shift invariant adaptive filters. Application of fuzzy theory in automatic washing machines, refrigerators, current home appliances, kitchen appliances. Application of system biology. We are using structural genomics jointly organized with the neural biology, statistical and biological physics sectors. Banach's fixed-point theorem has very much applications in image compression called fractal compression. It has application in space science. So we can say that functional analysis has high-end applications. Now, if we go to the differential questions, ordinary or partial or Fourier analysis, we can see a long list of applications like in physics and engineering, sound waves, supersonic airflow, crystal growth, cryocooler modeling. This cryocooler modeling is very important and India is working nowadays on it very much. Our organizations like DRDO and other things, they are working on it to develop the cryo engines. So cryocooler modeling is very, very important and currently only few countries have this facility like Russia, USA and some European countries. And now in Asia only China has this facility. So this mathematical thing is very, very high end and defense sector application thing which we use, which we teach in mathematics. Casting of materials in material science. Electromagnetic analysis for detection by the radar. Now casting of materials. Now everybody is using car or motorcycle or any of the applications. So I will give some applications of it. Like if the piston of a car engine just gets 1 mm more diameter than the actual one, then that piston cannot be fitted in the engine of the car or engine of any vehicle. So during the casting, the accuracy is very big role, very important thing in the material science or in the casting engineering. Material constitutive modeling, equation of state, underwater acoustic signal processing. Nowadays we are using the acoustic submarines or we are using torpedoes. We leave them in the seawide level and they collect data from there and they send those data to the earth stations. In this technology, China is doing too much. China is exploring the seabeds worldwide nowadays by using their spy torpedoes. So we need to work in these areas. These are highly technological things and highly important for the development or for the defense of the country. Recently, simulations for the space shuttles, we are using ODPD and numerical analysis, rocket launch trajectory, motion of a space vehicle, aircraft landing field length, nonlinear dynamics, and many more. Navier-Stokes equation we are using in the fluid dynamics too much. We calculate, we model the blood flow in the body using Navier-Stokes equation. We calculate the quantity of the medicine. Or nowadays we have radio medicines to cure the cancer peoples. So they calculate the quantity, how much quantity to be given to the particular patient according to their weight, age and height. Now if we see this example I took from my own book, whenever we model the fighter planes, we use the PDs, the modeling of the PDs. So this white color is a cloud of energy waves. When the fighter plane crosses the speed of the sound, there exists this type of cloud which is highly energy cloud, and in the beginning this was breaking the fighter plane's tail. So NASA took this picture using its spectrometer telescope, and then they found this problem, and because it is not visible by the naked eye, it is visible only by the spectrometer, and then they designed the aeroplanes in this way. So nowadays it is very tough. This technology is available with very few countries. Like India has this technology to develop the semi-supersonic or supersonic aeroplanes. Russia, European Union, China, and America. So we must give the knowledge of our student in this area as well. Whenever we teach the जब भी हम पार्शियल डिफरेंशियल इक्वेशन या ऑर्डिनरी डिफरेंशियल इक्वेशन या न्यूमेरिकल एनालिसिस अपने स्टूडेंट्स को पढ़ाएं, तो हमको उनके एप्लीकेशंस के बारे में बताना चाहिए कि इस नॉलेज का आप कहाँ पे एप्लीकेशन कर सकोगे. रेडियो इंफॉर्मेट्री, फ्री मेसन इन न्यूक्लियर फिजिक्स. So these mesons are developed in the nuclear reactors. So we use those knowledge in the day-to-day atomic energy powerhouse stations. Seismic waves propagation, how it propagates in the earth. Analysis of PD, I already told them, radar imaging and so on. Some of them are here. I will summarize these in the table. Then topology, we are using topology in different parts like homotopy type or proof assistance. Nowadays, this is very latest technology. The most popular of these proof assistants use their basic legal logical language, a syntax called Martin law of intentional type theory. I'm using one software from Hindavi, and they are using these algorithms, and they call Hindavi typeful.ai. They use artificial intelligence to correct the English grammar. We call it proofreading software. So they are using topological things, they are using artificial intelligence of the computer science, and they are using English grammar things, and they correct the manuscript English grammar, SES or sentence paraphrasing, everything. And nowadays even the Grammarly using these technologies. In India, people are using Grammarly software. So in robotics, we are using this algebraic topology. We use in sensor network design. We also use in the motion planning of the robots. We also use this in the survey articles. We use this in economics, like Brouwer's fixed point theorem. We use very much in the equilibrium points to find the solution of the problem in the economics. In geometry, we use in the quantum field theory, geometric topology. Group theory, we use generating algorithms. And cryptography, as we know, we already discussed. Ring theory, we are using Google PageRank algorithm, a very important aspect of the ring and algebra theory. Nowadays, whenever we search anything, जब भी गूगल में हम कोई वर्ड टाइप करते हैं और हम उसके बारे में सर्च करते हैं, तो गूगल अपने जो पेज स्टोर हैं उनकी एक रैंकिंग कर रखा होता है कि जो मोस्ट एक्यूरेट है उसकी रैंक लोएस्ट होती है, मींस 1. जो मोस्ट अप्रोप्रिएट है उसकी रैंक लोएस्ट, और जो लेस है उसकी रैंक हाई होती है. तो जैसे ही हम कोई कीवर्ड हम गूगल में टाइप करते हैं तो वो पेज रैंक के हिसाब से हमको उस जो उसके यहाँ इंफॉर्मेशन स्टोर है उसको एक्सेस करके हमको रिजल्ट देता है. तो इसलिए जब भी हम कोई चीज सर्च करते हैं तो हमें बहुत सारे पेज एक साथ खुलते हैं, लेकिन जो मोस्ट अप्रोप्रिएट होता है वो सबसे ऊपर होता है, उसकी रैंक सबसे कम होती है. एंड दैट is the Google's page rank algorithm which we are using nowadays. Now if we go to different sites like differential geometry, it has high-end applications in aeronautical engineering, in shipping, planning of shipping routes, planning of aero routes, like how we can travel using shorter distance from India to suppose USA. So the aerial travel is not like the land travel. In land, normally we are using almost a linear path. But whenever we fly in the aeroplane, we are not using a linear path. We are using a curvilinear path. So we use a curve around the earth. So that's why we use the differential geometry or differential geometry of manifold there, and we use these areas to design the routes. Now, if we go to the other sides, we can say differential geometry and computational geometry we are using in terrain modeling, computer-aided design of mechanical parts and assemblies, molecular beam spectroscopy modeling, color balance in photographic system. Yes, this is very important. I can give very clear example. Whenever you go for a photographic shop, you ask them, clear this spot from my face. Put hairs here. Do this. Give little bit fair color. How this is happening? This is happening by the use of fixed point theory in the software. We are using fixed point theory here to do the color balance of the photographic system. Optics for design of a reflector, cryptology, airflow pattern in the respiratory tracts. Nowadays, due to the corona, this last point is too much used by the doctors, by the modeling people in the health sector worldwide. If you see the other areas, motion planning, elliptic curve cryptography, statistical modeling, we are using algebraic geometry. We are using algebraic geometry in projective geometry and multiplication in the 3D image reconstruction from multiple camera views. So whenever we want to reconstruct the image, we use it. Now, if you can see the particular example, whenever teams are playing the cricket, they are using it from different directions. The cameras are sending the image, and they are merging them and transmitting to the viewers. Now, sorry, I am getting some disturbance. Is my time over? We have number theory, information theory, representation theory. We have so many applications. Let me summarize all of them in a table. So what I discussed in this lecture, Neeraj, let me summarize. Neeraj, let me summarize. Audience, can you give me a piece? I am getting lot of disturbances. Okay, complex analysis and transform theory. Now, we are using this in image processing, representation of 3D rotations, quantum computation, flow, fast and airfoil, oil and gas exploration, reanalysis, discrete dynamical systems, convexity and optimization, algebra and number theory, cryptology, crystal symmetry, protection of financial accounts, function analysis, classified areas of technology, fractal compression, genomics, economics, etc. If we go to differential equations, I already discussed this. Numerical analysis, essentially all high-end applications like MRI, radar application, calculation of airfield or airstrip. Everywhere we are using numerical analysis. Topology, proof engineering, CT scans, sensor network design, robotics, group theory and rings, spectroscopy, simulation, differential geometry, computer-aided design, 3D imaging, shipping routes, GPS systems. India already developed its own GPS system, so we are using differential geometry of manifold there very much. Our ISRO people are using it. Dynamical systems, modeling flow of liquids, formal systems and logic, computer security and verification, discrete mathematics, communication and information security, we are using discrete mathematics, nonlinear control theory, operation of mechanical and electrical systems, computational fluid dynamics, we are using aircraft and automobile design, oil explorations, optimization in asset allocation, shape and system design. In share market, we are using it too much. Parallel algorithms, wealth modeling and prediction, crash simulation. Statistics, we are using in design of experiments, analysis of large data sets, stochastic processes, signal analysis. And that's the end of my talk. I have some more applications, but I think time is not allowing me. So I will give floor to the audience. Audience, if you have any questions, you can raise to me. I will reply. I will try to reply your queries. Neeraj, mic is over to you. Dr. Neeraj, can you hear me? Dr. Neeraj, can you hear me?
Yes, sir. Yes, sir.
Yes. You can ask the audience if they have any query.
Yes, sir. One more, sir. One, sir. एक सर क्वेश्चन है सर मेरा सर, क्या मैं पूछ सकता हूँ सर?
बिल्कुल आप क्वेश्चन पूछने के लिए तो बोल रहे हैं
सर। अभी सर आपने सर एक एग्जांपल दिया था स्टार्टिंग में मैथ से संबंधित कि जिसने मोर के सर पे क्या कुछ वर्ड बोला था वो, एंड सांप के सर पे मणि होती है, वैसे भी एक मैथ का जो होता है मैथ, तो ये जो मैथ का आपने वर्ड यूज किया किस लेवल सर मैथ का मैं सुनना भूल गया था वो यस सर।
ये जो है एक श्लोक है संस्कृत में, like the crest of a peacock, like a gem on the head of a snake, so is mathematics at the head of all knowledge. ये संस्कृत का श्लोक है, मैंने उसको ट्रांसलेट करके लिखा हुआ है।
सर बहुत अच्छा श्लोक था, इसलिए सर मैं सुनना चाह रहा था दोबारा, इसलिए सर मैंने पूछा आपसे। थैंक यू सर, थैंक यू वेरी मच।
नहीं, इसका जो संस्कृत का श्लोक है वो आपको वेदांग ज्योतिष में मिल जाएगा, आप गूगल कर सकते हैं। मैंने जो भी इंफॉर्मेशन ली है उसको टेस्टिफाई किया है यहाँ रिकॉर्ड करने से पहले, सारी चीजें मैंने टेस्टिफाई करी है यहाँ आपको बोलने से पहले।
थैंक यू सर, थैंक यू वेरी मच सर।
नाउ
यस
संतोष कुमार सर के बेहद महत्वपूर्ण और बहुत ज्ञानवर्धक प्रेजेंटेशन सर ने दिया है। सर मैं आपका बहुत बहुत आभारी हूँ और बहुत धन्यवाद प्रेषित करता हूँ सर, जो आप निरंतर हमें सहयोग प्रदान कर रहे हैं सर। अब मैं हमारे इस कार्यक्रम के जो सेकंड
थैंक यू डॉक्टर नीरज
सो मच सर। मैं हमारी जो सेकंड एमिनेंट
प्लेजर, feel very proud and happy.
Now I would like to invite our second speaker, our second eminent speaker, Dr. Santosh Kumar sir, for their address. Dr. Santosh Kumar sir, please. Dr. Umesh Kumar sir, please. डॉक्टर उमेश कुमार सर कंप्यूटर साइंस के एसोसिएट प्रोफेसर हैं पंजाब विश्वविद्यालय में, और डॉक्टर उमेश कुमार सर।
गुड आफ्टरनून वन एंड ऑल, इज आई एम ऑडिबल? यस ओके, जस्ट लेट मी स्टार्ट। My screen visible now? Yes, sir. Okay. First, I would like thanks to Dr. Neeraj for inviting me in such a great talk related to real life, real-time application of mathematics and computer science, right? Myself, Dr. Umesh, currently I'm working with Chitkara Group as a professor in computer science engineering and head for computer science. I would like thanks to you all for organizing such a great talk, and as well as students for participating in this talk. In this talk, I will discuss various applications of computer science, as well as how we can interrelate computer science with mathematics, as well as I will also show you a few of the implementation part, how we can interrelate mathematics, how we can use mathematics in computer science. If I am saying about computer science, that you can see in this definition I already mentioned here. Computer science is the study of computers and computing, as well as their theoretical and practical application. It's a general definition of computer science, but you can see here in computer science there is a role of computer science as well as mathematics also. The entire computer science is based on the application of mathematics, which help us to build the engineering application, logic development, some functional part. And now in these days, we can say all the applications of computer science, all the techniques that we are using are directly and indirectly related with mathematics. As Dr. Santosh already discussed a few of the great applications like MRI, space science, and that I will show how we can use mathematics and computer science for this MRI analysis and other. I just want to show you the relationship between this computer science, mathematics, and this engineering. By this diagram, you can see you all are from mathematics background. You can understand this. This is showing the union of these all the components: computer science, mathematics, and engineering. That is science and engineering. So based on that, I can say whatever the latest technologies available in real world. In the current scenarios, most of the techniques are directly and indirectly using this mathematics. I will show you a few of the techniques which are based on this mathematics. Okay. You all have idea about artificial intelligence. I will show you how artificial intelligence is interrelated with this mathematics. What exactly artificial intelligence? Artificial intelligence, this word was firstly described in 1956. And the father of AI is first time when he discussed in a conference. It was also a mathematics conference where he described in future will just develop a machine that can work, think like as a human being. Okay, and based on this AI, there are few technologies like machine learning, deep learning, which are this part of this, as well as data science, statistical analysis. Okay, we all are in our real life facing various applications. We are using various applications which are directly and indirectly related with this machine learning and deep learning. I'm just giving you a few of the examples. Some students are also there. I just want to ask how many of you have experience of shopping on Amazon? Yes. You all are doing online shopping on various applications like Amazon Shopping, Flipkart, and other apps also. You have experienced that. Suppose if you are looking for a product on Amazon, right? Then in future, Amazon is showing you the same, I can say, similar type of advertisement or configuration. Like suppose I have to purchase a laptop, and if I'm looking for a laptop over Amazon, then when next time I will just start my search, automatically I will get the response from Amazon related to my previous search. How it's happening? Is there any team behind the system? Is Amazon appointed various persons for dealing such types of queries? Yes? No. They are not doing anything like that. They have one machine learning software. They have some machine learning technology. And this machine learning, you can see here, this is the working of machine learning technology, how exactly it's work. Machine learning basically based on a training model, which mainly work on previous experience data, I can say historical data, that is called the training data. And based on that training data set, we just train the model. And once this model received any input, like you can see in the diagram here, and based on that, this model respond. And this input is called here testing data set. So that is the overall behind this machine learning that we can apply at various places. It has various applications like in online shopping. Once you are looking for a hotel, just once you will search a hotel near me, then automatically Google will respond accordingly by applying this machine learning. Various algorithms of machine learning are available now these days, like supervised, unsupervised, and these all the applications are using mathematics. I will show you a few of the examples which are based on this machine learning, as well as there is one more technology, that is deep learning. That is also improved form of this machine learning, where we have huge number of data, and where we don't have exactly I can say training data set, as well as we just want to you can see here in this diagram, I am using some feature extraction classification. What exactly here I am applying in deep learning? We are using few of the training data set, as well as we are applying some calculation. And this calculation is based on some mathematical function that is called deep learning function. And this function have different layers, neurons, and based on that we will get the output. I will show you how we can implement this. I will show you a few of the codes related to Python, how we can apply mathematics here. I have one more example that is just will discuss a few latest application of this deep learning in various sectors, like in medical, agriculture, pharmaceutical, autonomous vehicles, in data center. Directly and indirectly we are applying deep learning with mathematics. In field of mathematics, if I will say, there are various fields like statistical analysis, linear algebra, operation research, that help us to find out to extract the information from the particular data set of a particular data. If I'm saying about the data is just only a raw fact. Okay, it's not a summarized form. It's not meaningful. But when I apply some computer science model, it can be like this machine learning model or deep learning model. Then based on that, I can say it will produce the information. Let's assume here in this slide, you can see the application of medical, where I can find the skin cancer by using this machine learning technology, deep learning technology, as well as we can apply some FDA approval for we have to find out whether the patient is dead or not. Some radiology application. In agriculture, there are various application in field of agriculture. Like I have to find out disease in plants. I have to find out the quality of crops, where we apply some IoT based application also. In pharmaceutical also in designing of drugs. Yeah, kindly mute yourself. Some disturbance.
Sorry, sir. Can you make it full screen?
Yes.
Can
sir.
you make it your full screen?
Yes. Dots visible, sir? Dots visible, sir?
Now.
Okay.
Yes. Now it is visible.
Okay. So various sector where we apply machine learning, deep learning with mathematics. The latest idea where deep learning technologies applies the autonomous vehicle system, driverless cars, like Tesla developed one car that is mostly used by USA and Canadian people, where a automatic driving system as well as the automatic transmission system is applied by this technology. What exactly happening in this technology? We are using some deep learning model which is collecting the information from the real world environment. That is the I can say road transmission systems, where the communication is possible by using radio signals, IoT-based traffic simulators, and as well as GPS technology, some sensors for collecting data and signals from these devices, and that will transmit to this deep learning model. And then this deep learning model has some functions which are based on mathematics, and based on that it will perform the calculation and will generate the result. Another application in field of data centers, where we apply this deep learning just to identify the intrusion detection, to recognize some false alarm system, the security of data centers, in traffic analysis, what are the various data which is transmitting from the data center, as well as what data is received by the data center. That is the few of the application of this deep learning, where we are applying mathematics also. One more buzzword, you all know about this cloud computing. What exactly this cloud computing and how we are interrelating mathematics application with this cloud computing. What exactly cloud is representing? Cloud is basically in cloud computing, this cloud is representing the internet, a network, and that allows us sharing of computing resources. Like in real life, suppose someone had to construct a house, okay, then simply he have one choice: either he can just hire some laborers, and he can just purchase the materials, and based on that he will just construct his house. Another way, he can just hire a contractor, and he will just give all the he have to just pay the amount whatever contractor is asking, and based on that the contractor will compute all this related to his house requirements. Okay, similar thing, this is a service based model. Same thing is happening in cloud computing. What exactly cloud is doing? Cloud is also providing that what I discussed in the second case, where a contractor is providing service to us. Similar cloud service providers are providing services to us. How mathematics helping us? Just when you want to store your data over cloud, just to analyze the traffic, how a cloud service provider map with cloud service user. For mapping, there are various functions are used, and these functions are based on mathematical calculation, mathematical application. I will also show you how it related to this. Yes. And one more computing, that is the edge computing. That is also another highly buzzword that is used by this of the cloud computing. Edge computing is also similar to the cloud computing. The only difference is there. In cloud computing, the things are, there is a gap between, I can say, the computing and the storage, right? And the devices. But what exactly in edge computing? In edge computing, all the things are directly related to the particular computing. That is the edge computing. I can say where all the things are hosted directly on the particular computations. There are the few of the application that is directly related to this computer science: image processing, education, industry automation, agriculture, healthcare, weather forecast, banking, and accounting. Now I will show you few of the real life application where I can use mathematics by using this computer science application. I will show you how we can implement. Just I was discussed, like even Dr. Santosh also discussed some MRI analysis. In my last example, I discussed related to crops analysis. Now I will show you how we can find this analysis. I will show you few of my implementation which are based on this. These are the Python implementation that I have implemented on Keras. In my last research article, I use one student performance model, how we can measure the performance of a student. You can see in this model, just I will show you how mathematics we are applying here. In the beginning, once you will see, we are using few of the libraries here. Here word is NumPy, and this NumPy numerical Python, that is related to the mathematics. So based on that, I can say there is a huge relationship between, already sir has given one slok in Sanskrit, Based on that, you can see NumPy is on top of all the libraries which we are using in this implementation. Okay, because NumPy is showing here numerical Python, and whatever the numerical functions are available related to statistics, algebra, OR, that is available in this built-in libraries of this Python. And once I will run this code, what exactly we are doing here? We are just checking the performance of a student, how a student will perform in the examination. That is related to some programming part that I am not going to explain you how it's happening. It was just related to my research. I just want to show you how it's exactly work and what will be the role of mathematics here. You can see at various places, like I have to check how many students passed in mathematics examination. I'm using here few of the condition, some mathematical conditions we are using here. Okay, and based on that, once I will run this application, the results will be also in a graphical mode, in a statistical form, that I will show you how it is producing the results. It will take time because we are using few data sets here, and how mathematics help us, whatever the data sets we are using, sometimes maybe some anomalies in the data set, some missing values are there. You can see, I will just show you a few of the results. These all are the results here. You can see maths score, reading score, writing score, how many number of students, these are the counts, mean value, standard mean, how many students are 25%, 50%, 75%. These are the statistical analysis. In this research, I'm using the record of 10,000 students, and based on that, I got this result. And once I have to see the graphical form of this, you can see here, this graph is generated by Python. Based on that, you can see how many students, what exactly the score of students in mathematics. These are the count of students, and these are the mathematics score. Similar for other subject. This is a great application of mathematics. These all are possible because of mathematics only. If we don't have mathematics calculation, we can't produce such types of results. You can see here. In another graph, I'm using one, how many number of students pass in the examination, what is the count of the student, and similar I have different graphs and analysis for various students, as well as we can see these all are related to implementation part in Python. Similar, I can show you another application like already Dr. Santosh already pointed this, the credit card analysis. I will show you how this credit card, this is a great application of computer science. Suppose if I have one data set and I have to find out whether the person is reliable, whether a company should issue him a credit card or not, how a company person should just, a bank should decide based on the credit score of that person. We can find out whether the person is a genuine person or is a fraud person. So for that research, again, we are using few data sets. I'm using here PCA method, and there are few of the parts. Again, you can see we are using some mathematical libraries, numerical Python, some matplot library here. Again, some graphical objects here, graphical libraries. These all are related to some coding part that I'm not going to explain here. Just I want to show you how this application will run and how it will produce the result. In this application, again, I'm using few of the data set which I have just taken from online Kaggle site, which have 20,000 records of credit card customer based on their previous history, whether they are paying their credit cards bill clearly or not. You can see once I generated the overall analysis, there are a number of graphs. It's exactly related to research work. I am not going to explain this all the terminology here. Just I want to show you how we can use mathematics and computer science for such types of research. a few of the students are also attending this session, they can also utilize their mathematical skill in such types of application in data science, and for that there is no need of coding even. This is related to coding. I am basically related to computer science, so my part is related to coding. But as a mathematician, you can also help in data science by designing some statistical analysis, some statistics function in field of operation research. You can see here, these are the various results that I have just calculated for this credit card analysis, and based on that I have created few of the graphs that I will show you what exactly these graphs are showing. How many time is required for calculation this, that is the total amount based on the hours and some. Another graph. This what exactly this class 0 and 1 is representing here. Class 0 is representing all the defaulters. Whether a organization should issue a credit card to this persons or not. What exactly this class 1 is representing, these are the genuine person and we can trust on them and we can issue a new credit card, right? So this research analysis is also based on this. And suppose if I have to manually perform these all, it will take huge time and maybe there can be some possibility of inaccuracy. But if I am using such types of model, mathematical model also, then it will help us a lot to find out exact result. One more analysis just I will show you related to one of my research that is related to how to find out the Omicron cases. We all are facing the COVID issues now these days for last 2 years, and that's why this meet is also virtually. And suppose if I have to find out what is the exact Omicron daily cases, how Omicron is getting increased, I can also implement such types. I can implement one model that will help us to predict to find out exactly the count of such types of disease and as well as the spreading rate. I will just show you how it's happening. Similar, there are other applications also like cassava leaf disease detection. I have just recently published one article on this research. Now these days, the Indian government has just launched some agriculture-related drones, and these drones are equipped with sensors and infrared cameras. These cameras capture the images, and based on that, that data will transfer to a deep learning model, a machine learning model, and these models will analyze these images, and based on that, it will produce the result whether these crops are infected by a particular disease or not. That is just recently launched by Indian government. We'll see how Omicron cases are increasing. This is also related to one of my research, where I am applying huge mathematics also. You can see here, country-wise records like how Omicron cases are increasing. That has just generated based on the data set. These all are the graphs which I received after running my application. So I'm not going to explain the coding part here. Just I want to show you how mathematics helping us here. All types of analysis which I am showing you here are based on the mixture of computer science as well as the mathematics. These all are from my side. I will just show you few of the real life applications. Few of the fields like cryptology. What exactly this cryptology is? It's also called cryptography, where encryption, decryption we apply. It also helps us in data computation, where we directly apply algebra. Simple mathematical calculations we use, where these applications help us to just accurately find what exactly the actual data and what exactly the encrypted data, whether the data is as per the actual requirement or not. That we can calculate by this using algebra application, as well as some scheduling of tasks used by computer in some processing, as well as once we run a program, once we use any of the application, how these applications will exactly schedule. This is mainly decided by this scheduling process that is also based on this algebra. Some pattern analysis, some crystal symmetry in chemistry, group theory, we apply this algebra. As well as another field of mathematics, that is differential equation. It also helps in various applications like analysis of sound words in ears. And these all are related to computer science. We can implement whatever the fields I'm discussing here. These all are related to computer science. Just suppose if I have to find out the quality of the material, whether whatever a product company is producing, that is the exact as per the requirement of customer or not. In quality checking of this casting of materials, we use some differential equation. That is also, I have also written one of the essay article on this casting of materials to exactly analyze the quality of the product. It helps in material science also. Some underwater acoustic signal processing, like there is one field that is called underwater wireless sensor network. Just for designing of cabling and designing of some I can say the communication system underwater, that is based on this differential equation where we apply some graph theory which help us to find out the shortest path or route among one source and destination. And there are other applications also like aircraft handling, heat transfer, that is used by mechanical people. In ME field we use PCA, principal component analysis, in photograph development. And another field of mathematics, that is differential and computation geometry, which helps also in various sectors like computer-aided design, CAD/CAM analysis, some terrain modeling. We have to find out the area of modeling, we have to perform some wireless sensor network simulation, wireless network simulation. We have to monitor one particular area. Some molecular beam analysis that mainly used in computation geometry. We have to find out some photographic color balancing in an image where we can apply this. And there are also some other sectors where we can apply mathematics. If any query from your side, this is from that all from my side. Yeah, thank you all. Thank you very much. Yes, if anyone have any doubt, any query from related to my session, can discuss. Am I audible?
डॉक्टर उमेश
Yes, yes.
सर के शानदार उद्बोधन के पश्चात सर ने बहुत अच्छा इनवाइटेड टॉक प्रस्तुत किया और सर ने कंप्यूटर साइंस, मैथमेटिक्स और इंजीनियरिंग के रिलेशन को काफ़ी अच्छे से समझाया, न केवल और बल्कि कंप्यूटर साइंस के विभिन्न प्रकार के अनुप्रयोगों से विद्यार्थियों को अवगत कराया। मैं डॉक्टर उमेश कुमार सर का अभिनंदन प्रेषित करता हूं, धन्यवाद प्रेषित करता हूं सर। थैंक यू सो मच सर।
Thank you very much. Thank you all. Thank you for listening. Thank you all. Thank you.
Would like to invite for vote of thanks HOD and NAC in charge Dr. Archana Singh Madam for vote of thanks. Dr. Archana Singh Madam.
First of all, good afternoon to all dignitaries. It's my great pleasure to pay thanks for the organizing such a wonderful program for our institute in Government Degree College Timarni. I want to pay my special thanks to Dr. Geeta Modi Madam for wonderful explanation of mathematics in daily life. I also want to pay my special thanks to Mr. Santosh Kumar sir and Mr. Umesh Kumar Lilhore sir. Here I want to pay again special thanks to giving such a time for our institute.
by organizing this meeting. Here I want to say that feedback form is sent in chat box. All the participants compulsorily fill the feedback form. Thank you to all.
अब मैं कार्यक्रम का मुख्य आतिथ्य ग्रहण कर रही डॉक्टर गीता मोदी मैडम से अनुमति चाहूँगा कि मैं इस कार्यक्रम को समाप्त कर दूं। डॉक्टर गीता मोदी मैडम और डॉक्टर संतोष कुमार सर से कार्यक्रम ओवर करने की परमिशन।
Yes, you can do it. Thank you.
हाँ, सभी प्रतिभागियों को धन्यवाद प्रेषित करते हैं और कार्यक्रम के समाप्त होने फीडबैक की लिंक आपको चैट बॉक्स में दे दी गई है और सभी ग्रुप में भी भेजी जाएगी और फीडबैक कल सुबह 6 बजे तक ही ओपन होगी लिंक। इसके बाद फीडबैक की लिंक ओपन नहीं होगी, इसलिए उससे पहले सभी लोग फीडबैक भर लीजिए ताकि आपके सर्टिफिकेट जनरेट हो सके। और यदि आपके सर्टिफिकेट अभी जनरेट नहीं हो पा रहे हैं तो विद इन 15 डेज में हम आपके ईमेल आईडी पर सर्टिफिकेट भेजते हैं।
सर लिंक वर्क नहीं कर रही है।